This video we're going to practice using the limit comparison test by comparing 3k squared plus 1 over 5k to the fourth plus 2k plus 2 with 1 over k squared. Now, one of the things before we even get into comparing this, how you might decide if you weren't given that. What we would look at are the highest powers on this side. Don't worry too much about the coefficients. So we'd look at that right there. K squared over k to the fourth. We would want something to have that form because that's the only way we're going to have a chance of the limit of their ratio being non-zero finite number. That reduces down to 1 over k squared. So that's how you might have chosen this if you weren't given it ahead of time. Now, the limit comparison test says we need to take the limit as k goes to infinity of the ratio of just their sequences. Don't worry about the summations. And it doesn't matter which one you put on top. So maybe if we take 3k squared plus 1 over 5k to the fourth plus 2k plus 2 all over 1 over k squared. So there's our a sub k over b sub k. Very first thing we're going to flip and multiply. And you're going to see that a lot when you're running the limit comparison test. So that's actually very common. So we got 3k squared plus 1 over 5k to the fourth plus 2k plus 2 times k squared over 1. All right. Now we're going to go ahead and multiply out. There's not too much multiplying to do. So we have the limit as k goes to infinity. This guy needs to be distributed, so be careful on that. We're going to have a 3k to the fourth plus k squared over 5k to the fourth plus 2k plus 2, since it only gets multiplied by 1. Now, you may already know the answer to this limit because of what we know about rational functions. This is a rational function with a horizontal asymptote at 3/5. If we needed to do a proof or wanted to show it via limits, one of our options is to use L'Hopital's rule because we have an infinity over infinity case. So after our first round of L'Hopital's rule, we'll take the derivative of the numerator and denominator separately. And we'll get 12k cubed plus 2k all over 20k cubed plus 2. Again, we still have a rational function. We still can see that now it's at, looks like it's at 12/20, which reduces to 3/5. Well, again, if we want to show it with limits, we'll use L'Hopital's again. It's good practice. Limit is k goes to infinity of 36k plus 2 over 60k. So really the big issue now is we got to get rid of that 2, and then we'll be able to reduce and finish. So we are going to use one more round of L'Hopital's rule. So we got the limit as k goes to infinity. One more round of L'Hopital's rule just ends up with 36 over 60. So that's going to be 36 over 60. Both of these are divisible by 12, and we get 3/5. That is a non-zero finite number. So, because or since our series 1 over k converges by what we know about p series, then the one we were given, our series 3k squared plus 1 over 5k to the fourth plus 2k plus 2 converges by the limit comparison test. So that's how we can use the limit comparison test to show convergence. If we compared it to a divergent series and we got a non-zero finite number for this limit, then they both diverge.